look at here is this mainly is quadratic equations. So one of the things we're going to look at is just all the different ways to solve quadratic equations. And hopefully most of this is going to be review for a lot of you anyway. I know I had a lot of you in my intermediate algebra class. So that's a quadratic equation. So that's ax squared plus bx plus c. We're going to look at all the different varieties of equations you can learn how to solve. So we're going to look at something like this. Then we're going to look at something like this. This is something that you call the square root property. Now, if you look at something like x squared equals 16, what is the answer to that problem just in your head? 4, but there's another answer. -4, good. Okay, so what you do is if you have something squared equals a number, what you do is you take the square root of both sides, like that. So you get x, and one of the things you got to remember how to do is anytime you take a square root of both sides, you put a plus or minus in there because there's a plus answer and there's a minus answer. So we would end up getting the answer, one of the answers would be 4, the other answer would be -4, like that. Okay, can you guys see what I'm writing? Okay, isn't that this clearer? Okay, it is to me, okay, and I don't have to worry about this bad camera here because it's not a very good camera. Okay, so that's how that goes. Now let's do this next one, and this one is x minus 5 to the second equals 10. What students always want to do on this problem is they want to FOIL that out. That just because you're trained to see something to the second power, you want to FOIL. No, you don't do that. What you do is you take the square root of both sides, just like I did the last problem. So you do square root there, square root there. Now, if you do the square root of something squared, it just undoes the operation like this. And then you've got to remember to put a plus minus there. Because anytime you do a square root of both sides, you're getting 2 answers. Quadratic equations are going to have 2 answers, okay? Now, you want to get x by itself. So what you do is just move the 10 over there, or you could think of this as, you could think of it as adding 5 to both sides if you want to. And when you add 5 to both sides, you want to develop the habit of putting the 5 first in front of the plus or minus like that. Okay, so that's how you want to write your answer. You can write the answer that way, or you could write it as 5 minus radical 10, comma, 5 plus radical 10. There's 2 answers. That plus or minus is just an abbreviation. Okay, now those of you that took 055, does this look familiar? Yes. Good, okay, all right. If you didn't, this stuff needs to come to you pretty quickly here, because there's going to be a lot of Chapter 3. There's going to be a lot of review stuff in Chapter 3, which actually helps students in college algebra. That's a good thing. Okay, so let's go through and just kind of work these problems down at the bottom here. What is the answer to number 2 in your head? 5 and -5. Okay, good. So you just take square root of both sides. Okay, and when you do that, you get x equals, really you're doing plus or minus square root of 25, so that's equal to plus or minus 5. Okay, and you can write it that way. As long as you know that the answers are -5 and 5, you can write it in that abbreviated form like that. Okay, and that's how that goes. Now, some of these things I'll check, some of them I won't. This one's easy to check in your head. I mean, what are you doing? You're doing 5 to the second's 25, right? And -5 to the second's 25. That one's easy enough to check in your head. Okay, let's look at the situation that happens on this one then. Okay, so again, we're going to take the square root of both sides. So when you do that, what does the left side become? X. Now, don't forget your plus or minus in front of the square root of 12. Now, we've done this a little bit in this class. You've got to break up the 12 because it has a perfect square factor. What do I mean by that?
3 and 4.
Yeah, 3 times 4. Good. So we have to say plus or minus square root of 4 times square root of 3. So then if you do the square root of 4, what do you get? You get 2. So you would have an answer of plus or minus 2 times the square root of 3 like that. Okay? And again, you can write it that way. I believe when you start doing homework on My Math Lab, you don't need to worry about that until the weekend. What you do on that is they require you to type both answers out. Okay? It's not necessary. You don't have to do that. Now let's check one of these answers. So what we're doing is we're doing something squared equals 12. Okay, now I'm going to plug in one of the answers. It doesn't matter which. I'm going to put in the negative one just because it's got a negative in it. Okay, so what you need to do is verify that that works. Now, if you are taking something and squaring it, what are you doing? You're multiplying something by itself, right? Okay, now that's not a FOIL problem. I see students FOIL this all the time. there's not plus and minus signs separating stuff. So what you just do is -2 times -2 is 4. Then you're doing the square root of 3 times itself, so that's the square root of 9, right? So what do we get? 4 times 3, we get 12. That's how it works. I think it's real important that you understand how these things check, because it'll help you understand why this is the answer of the problem. Okay, do you guys follow that checking okay? Okay, just plug it in and square your answer. Now, if that answer works, the other one's got to work. That's kind of the way these things work out. Okay, all right, let's do this one. Okay, so again, what we're looking at is square root of both sides. Okay, we probably have a factor on this one that we got to play with too. So that's going to be x. Don't forget that you have your plus or minus square root of 162. Okay. Now, there's all kinds of numbers that have square roots. There's several ways you can do this. You may know what that number is automatically. It depends on your skill. But if you were to go through and divide this by 2, because it's an even number, you get 81. What's special about 81? It's a perfect square, exactly. Okay. So if you don't see a perfect square factor, just kind of start playing with the number until you find one. So what you'd end up having then is x equals plus or minus square root of 81 times square root of 2. So what's the final answer? Plus minus 9, radical 2 like that. Okay? And one thing I want to explain on this too, with a little practice, you can learn to tell you right in your head. Okay? Because what are you doing? You're squaring this. So what is 9 to the second? 81. What's the square root of 2 to the second? 2. What's 81 times 2? 162. Okay, you can do that. Okay, if you can do that and manage that in your head, it helps you understand why that's the answer to the problem. So that's kind of a good way to look at those problems. Okay, any questions so far? Okay, all right, I'm going to do one more, then I'll let you do a couple of problems. So let's go down to this number 5. This one just has one slight twist to it. Okay, so we have 3x squared minus 39 equals 0. Now what you have to do on a problem like this that's real important on this is the first thing you always want to do is you want to isolate this. Look at this. I can use all kinds of colors. This is so cool. This is like a dream come true for a math teacher. Okay. Back when I started teaching, I used dittos. Do you guys even know what the ditto machine is? And then you would just pass out your test to the students and they would smell them, and it smelled so good. You guys don't even know what a ditto machine is. I'm that old. Wow. Okay, we didn't used to have copy machines, believe it or not. All right, anyway, so what we're going to do is we're going to add 39 to both sides, like this, okay, and that'll cross out, and then that'll give you 3x to the second is equal to 39, like that, okay. Then what do you need to do? Yeah, divide by 3. So if you do that, you're going to have x squared is equal to 13. Then what do? Square root of both sides. Good. Okay, don't forget the plus or minus. That's a real important aspect of this. So you'll have plus or minus radical 13 as your answer to your problem. Okay, now let's just check one of these one more time. So if you were going to check your answer, you're checking 3x squared minus 39 equals 0. So if you plug the answer in, and let's just plug in the negative one like this. Okay, what happens to this piece right here? When you square this radical, what happens to that part right there? Radical comes off. Remember, if you square a radical, square root, it comes off. So that's just going to be 3 times 13 minus 39 equals 0. Now that's going to be 39 minus 39, so that's equal to 0. Okay, so one of the general things that you want to know about is if you take any radical, a square root, and square it, it's the same thing as doing the square root of something squared, so the radical just comes off. That's a helpful thing to learn as you're doing this section. Okay, so I'll just give you guys a few minutes to do 6 and 7, see if you can get those okay, then we'll kind of proceed through a few other things on here. And you can write these in that, abbreviated form if you want to. You can always have plus or minus, but don't forget that plus or minus because it's a huge part of the problem. So what is the answer to number 6?
Negative 12 and 12.
Negative 12 and 12. Good. You can do that one in your head if you want to. Sometimes you can do it in your head. So you can write it as plus or minus 12, or you can list the two answers out. Okay? What did we get on 7? I don't want decimals either. I just want square roots. Square root of 13, maybe?
13.
Yeah, there we go. Okay. So what you want to do on that, you want to start by dividing by 2, like that. So that's going to give x to the second equals 13. Then you square root both sides. So you get x equals plus or minus square root of 13. And leave it that way. Don't get your calculator out or anything. Just leave it alone. Okay? Radicals are radicals. That's the perfect form. Simplify them if you need to. Okay? All right. So this is called the square root property. We're going to look actually at 3 different ways to solve these things. This is the one that's the easiest to learn. Okay. So when we do this next thing here, if I go through on this one, the way that you want to start this problem out is by doing what? Isolate the x squared, exactly. Okay, because you can't do the square root of both sides until you do that. So you want to start by just doing this. And you can do this in your head if you want to. So you get 5x to the second equals negative 65, like that. Okay, then what you'd want to do is divide by 5.
It'll be negative 13.
What's that?
Negative 13.
Oh, okay. Negative 13, okay. All right, so we got that. Now you take square root of both sides. Now this is stuff that you're going to need to review in 3.1. So you have x equals. Now what we do on this, we're kind of used to that not being a real solution. But what we do now is we start looking at imaginary numbers. So this is the same thing as square root of negative 1 times square root of 13. From your background, do you guys remember what we use for the square root of negative 1? We use I. Good. Okay. So this is one of the things I want you to review a little bit over the weekend. So this is going to be plus or minus I radical 13. Okay. You don't say the answer has no solution because it does. It has an imaginary solution. So if you're taking that square root of a negative number, just write it like this. And you can learn to do this in your head. I mean, if you have the square root of negative 2, you just write that as I radical 2. Like that and so forth. If you have the square root of negative 5, how do you write that? I radical 5. Just learn to do that. It's an imaginary number. That's what we do. Okay? All right? Okay. Now this next one is going to have a slight twist to it. So we got x minus 6 to the second is 49. Don't go through and FOIL this. That would waste your time. What you do is you have a square isolated. So what you're going to do is you're going to do the square root of both sides like that. So what's the left side going to be? X minus 6. What's the right side going to be? And don't forget the plus or minus, okay, because you have to have that. If you forget that, you're going to miss an answer. So now what you want to do is you got to add 6 to both sides, and you can just start doing this in your head. You just move that 6 to the other side so it becomes positive 6. And put it in front of the plus or minus 7. That's the best habit to put together. Now don't stop there. I always see students stop there. Go ahead and work it out. So what you're going to do is you're going to get 6 plus 7 is 13. So that's one answer to the problem. Then you're going to do 6 minus 7 is negative 1. So that's the second answer to the problem, like that. Okay, so sometimes you need to go through and work those two things out like that. Now one thing that's important on this, if you haven't done this in a while, is if you add that 6 to both sides, be sure you put it in front of the plus or minus. That's the best habit to develop as you're doing these problems, okay? All right, does that look okay to everybody? Okay, all right. So this number 10 is very similar to this. It's got one little slight difference. So you have x plus 3 to the second equals 24. So again, you just start like the last problem. You take a square root of both sides. You want to go ahead and do that. Okay, what's the left side?
X plus 3.
X plus 3. Now you have plus or minus. Now, what are you going to do with the square root of 24? Okay, how do you break it down? 4 times 6. Okay, why 4? 4 is a square root. Okay, so you have to learn to do this because this is going to pop up quite a bit. So what you have is you have x plus 3 equals, and then this is plus or minus 2 root 6 like that. Okay, 4 times 6. You wouldn't do 2 times 12 because neither of those have a square root. Now, move the 3. Where did I say to put that number? Thank you. In front of the plus or minus. That's a habit that's real important to develop. And now you're done. That's it. There's not a thing else you can do on that problem because those are unlike terms. You can't add radical 6 to 3 because they don't both, but one of them has a radical one and one doesn't. So that's the idea. Okay? So you're applying a lot of little things that we've talked about in the class. You're going to have to reduce radicals a little bit sometimes when you do those as well. Okay, so is there any questions so far? Okay. All right, let's do this, then I'll let you do maybe a couple of problems. And if you got this down, then we'll move on to the second thing. Okay, so this one, same as the last problem. You're going to do the square root property. The idea, you have something that's squared that's isolated. Okay, so what you want to do is start by doing this. So what's the left side? What's the right side? Did I hear somebody say 5i? Okay, all right. When you're doing this, it's an imaginary number. It's really the same as I times the square root of 25, but what's the square root of 25? 5. So you write that as 5i. Okay? So one of the things that will happen here a little bit, you can just get to a point where you just start doing this in your head. What's the square root of negative 9? 3i. What's the square root of negative 36? 6i. Like that, okay? That's how you do that. So now all you'd have to do to finish up this problem, again, is to move the 11 to the right side. So you would have x equals 11 plus or minus 5i. That's the abbreviated answer to the problem. I think like my math lab, and it's not a bad deal. They just force you to do it that way. It's easier for them to check. But those are the two answers to the problem, okay? All right, any questions? Okay, go ahead and try the next problems, and we'll take a little time to do that and see if you got the handle of it. And then we're going to look a little bit at completing the square. We're going to do kind of a quick review of the quadratic formula and a few other things. So again, my hope in this section is that you've got a good enough background that this is not a hard thing for you to learn. Either you've done this pretty soon recently, or it'll come back to you pretty soon. Okay, that's the idea. So I'll walk around, just give you a little time to work on it and see how everything goes for you. You will have some imaginary numbers on, it looks like the last two are going to have, or actually all of them have imaginary numbers now that I look at them. So I want to make sure you guys got the handle of how to do that then, so that's good. Okay, you're fine. Okay. Don't forget your plus minus there. Yeah, because we did square root of both sides, because you're always going to get two answers on these problems. So you're doing okay. And then you just need to isolate the x, and you should be able to get that okay. Okay, now we'll use the first thing you got to do on that is you got to move the 64 to the other side. You got to isolate that square. So you start by having x squared equals negative 64. And you can take it from that point. That one, when you do the square root of 64 is 8. Okay, you could actually do that and so you would get 4 times 2. So square root of 64 is 8, so then you have plus or minus 8. You can use your calculator to help you a little bit with that too if you need to. All looks okay. Okay, so it looks like we're doing pretty good. I see a few little issues with the second one. Okay, so let's go ahead and go through these and see what we got on this. I saw a couple of you do this wrong. The first thing you got to do on number 12, you got to do that. You got to subtract 64 from both sides of the equation. You can't take the square root until the squaring part's isolated. So what'd you get as your answer? Plus minus 8i. Okay, square root of 64 is 8, so that would be plus or minus 8i. Okay, now the next problem, it's already isolated. The 2x minus 5 to the second's isolated, so that means you'd be ready to take the square root. So you should have just done square root. Some of you forgot to put the plus or minus, so that's 2x minus 5 equals plus or minus 5. Now when you do this, you actually really got to take this in two directions. So you got to solve the equation 2x minus 5 is equal to 5. Then you've got to solve the equation 2x minus 5 is equal to negative 5, like that. Okay, so if you did that, you should have got two answers. This one you could add 5 to both sides, so that's going to give 2x equals 10. So what answer does that give? 5. So I think I saw a lot of you getting x equals 5. And then this one, you add 5 to both sides, you would end up getting 2x equals 0. So what answer does that give? That gives 0. So if you divide both sides by 2, you're going to get x equals 0. Okay, so the two answers to this problem would be 0 and 5, like that. I think some of you didn't get that second answer because you forgot about the plus or minus. Okay, does that make sense? Okay, when you do that plus or minus 5 right there, you really got to solve two different equations. Okay, you have to. Okay, all right. Now let's see, this one had another issue in it. This one is x minus 7 to the second equals negative 45. So you're going to start this by doing square root of both sides, like this, and then you've got to have the plus minus. Okay, so this is going to give x minus 7 here. Now, how do you break up 45? How did you do that? 9 times 5, right? 9 times 5 is 45, and 9 has the square root. So you got to be on top of that because that's going to happen a lot as you're doing these problems. So that's x minus 7 equals plus or minus 3 radical 5. Then what do you do with the 7? You get rid of it, so you add 7 to both sides. So you can just do this in your head. When you move the 7 to the other side, that becomes positive. Yes? Oh, I forgot about the I too, didn't I? Okay, so that is a I, that's an imaginary number. So that would end up, you would have to have squeeze the I in there. Sorry about that. Okay. All right, so then you would have x equals 7 plus or minus 3i times the square root of 5. Okay, and then that's your answer. Okay, so that one right there has every issue in it. It's got the imaginary number, it's got breaking up the radical and that kind of thing like that. Okay, all right. How's that look to everybody? Okay, all right. So I'm going to work a little bit with completing the square on the next page. Now, you can go on to page 4. This just kind of tells you the methodology of doing this. And we end up doing completing the square a little later in the semester for other reasons. So we're going to solve this equation using this method. Okay, so watch carefully how I do this. Okay, what you always want to do on this is you want to have x's on the left side and any number you want to have on the right side, like this. Okay, you start this way. There's two things you always want to do. So if you have a 29, move it to that side. Now we're using a method here that's called completing the square. So what we're going to do is, that's x squared plus 4x. Leave a little gap there because we're going to do something there. So leave a little space there. And then when you move that, that becomes negative 29. That's the way you always want to start these problems is x's together, both of them together, and then the number on the other side. Okay? Now what you do in completing the square is what you're always really doing is you're always looking at the number in front of x. And you do two things with that. When you do that, you're going to take half of that number and then you're going to square it. So you take that 4, you divide it by 2, so that gives 2. Then you square that. So it's always half of the number, then squared. So now you're going to take that 2 and square it, so you're going to get a 4. Okay, that's called completing the square. Isn't the number 4 a perfect square? That's why we call it completing the square, because we get a square. Anytime you take a number and divide it in half, and then square it, you get a perfect square. Guaranteed. Okay, so what we're going to do is take that number and add it to both sides of the equation. We must add to both sides of the equation, or we're changing the problem. Okay, so again, half of that number, then square it like that. Okay, now what I'm going to do is we just kind of collect the like terms next. So now we're going to have x squared plus 4x plus 4. And on this side, that's going to give negative 25 like that. Okay, you guys follow what I've done so far? Okay, yes, no, maybe? Okay, now next thing we're going to do is factor. So we have done some factoring this semester. So we're going to do factoring, and I'm just going to bring down the negative 25 like this. Okay, so now when we factor this, we're factoring the trinomial, so you're going to have x and x. Okay, what are two numbers that multiply to give 4 that add up to 4? 2 and 2. And by the way, when you complete the square, factoring always works out the same way. You're going to have two plus signs to make the 2 and 2 add up to 4x. Okay, so I'm going to move the problem over here. What's another way to write x plus 2 times x plus 2? X plus 2 squared. Okay, look like, so we're going to rewrite this as x plus 2 to the second equals negative 25 like that. Does it look like a familiar problem? Okay, please say yes, because that's what we've just been doing. Okay, what do we do to both sides? There you go, square root of both sides. Okay, so we got that. Okay, so the left side is going to be x plus 2. The right side is going to be what? 5i, and it's going to be plus or minus, so don't forget the plus or minus when you do that. Okay, now what do you do with the 2? You just slide it to the other side. You're really subtracting 2 from both sides. So change the sign, and you're going to have negative 2 plus or minus 5i is the answer to that problem. Okay, that's called completing the square. Okay, part of the reason we teach completing the square is it's where the quadratic formula comes from. That's one reason. The other thing is we use it towards the end of the semester when we start learning about what's called conic sections. Okay, so I'll give you guys a few minutes to see what you can do on 17. Don't go to 18 because 18's got a different twist to it that I'm going to do. So just take a few minutes and see if you can run through that same process and get number 17 worked out. Okay, always start by getting the number, move the 26 the other side, complete the square, factor, and take the square root. So see if that's good enough for you to get a good answer on the problem. Most of the time on these problems you get radicals, although they can turn out to be whole numbers too. Sometimes they work out that way. You never really know until you play with it a little bit. So what do you add to both sides? 36. Okay, so I've kind of got the first couple of steps up here. You got move the 26, and then again you take half of 12, which is 6. 6 squared is 36. That's the completing the square step. Then once you get to this point, if you can factor okay, you should be able to get this fine. Okay. One of the things that always happens when you complete the square too is when you factor, you just get the same number twice. So what are you going to use for the numbers that multiply to give 36? 6. Okay. Where did the 6 come from? It came from here. Okay. So what you're going to end up having is x plus 6 times x plus 6. Then that side's equal to 10. So what you'd end up having is x plus 6 to the second. You're always going to have that when you complete the square. You'll have the same factor twice. Okay. Then what do? Square root both sides. That'll give x plus 6 there. That'll give plus or minus square root of 10. And then the last step is to move the 6 to the other side. So what's your final result? Negative 6 plus minus square root of 10. Leave the square root of 10 alone. It doesn't reduce. So leave it alone. Okay, like that. Okay, everybody follow that fairly well? Okay. All right, the next one you might not like as much, just because it has fractions in it. But what I'm going to do on this one is run through one like this, and then I think number 19 I'm not even going to have you guys do, because when I'm looking at it, it's the same problem. I just realized that. I might change that and just let you play with a problem like this a little bit. Okay, so when you're doing a problem like this next one, you're going to start the same way. You're going to start by moving the constant term to the other side. So that'll become negative 1. Now here's the slight twist to this problem. Notice that you have a number in front of x squared. Okay? If you have a number that's in front of x squared, then you have to get rid of it. If I want that 4 to go away, how do I make it go away? Good, I divide by 4. You have no choice. And when you do this, you're going to divide everything by 4. Okay, like that. That's what's going to make this problem just a little more challenging, is the fact that you're going to have a bunch of fractions. So this is going to be x squared. This is going to be 3/4. Leave a gap, that's got an x, and then negative 1/4 like that. Okay? Now, we are going to complete the square on this, just the same way we did the previous couple of problems. So we're going to work with that negative 3/4 when we do that then. Okay? All right, watch carefully what I do. What have we been doing with that number over and over again? Taking half of it, then squaring it, right? Don't be a decimal person either. Just leave the fraction alone. Okay? You want fraction answers. So how do you take half of a fraction? You multiply it by half. So that's going to give negative 3/8, right? How do you square a fraction? You multiply it by itself, right? So if you take this negative 3/8 times negative 3/8, that's going to give 9/64. Okay, so that's kind of a critical thing. Does that look okay? Don't do decimals, please. Decimals aren't as good as fractions. All right, what do you do with that 9/64? You add it to both sides. Okay, now believe me, I'm following every step on this like the problem that you just got through doing. Okay, so we got that. Okay, now what you get into is, well, we got a factor, and then we got to add those fractions together on the right side. So when we factor the left side, okay, now we're factoring this trinomial right here, you're going to have x and x. Okay, and don't fuss about the fractions because it's not that hard. What do you multiply together to get 9? 3 and 3. What do you multiply together to get 64? 8 and 8. So you're just going to have 3/8 and 3/8. And after all, see, that came from that first step. Okay, it's basically when you took the 3/4 divided half of that, that gives you the number. Then it's going to have 2 minus signs like that. Okay, does that look good? Okay, yeah.
If you have both negative, wouldn't the middle be
You're talking about this term?
8? No, on the x squared minus 3/4 x plus 9/64. On that, the middle would have ended up being 6/8. 6/8 if you have both negative.
Where are you getting 6/8 from? I'm sorry.
Because if you now multiply them, it'll be x squared minus 6/8x less.
Okay, 6 over 8 is 3/4 though, right? If you reduce it, 6 over 8 is 3/4, right?
Yeah.
That's why. What I did is I just, when I multiplied that straight across, if I take half of that number, I get 3/8.
Oh, wait, yeah, my bad.
Okay, that's okay. All right, that's no big deal. Okay, all right, so we got this. Okay, now what we're going to do is add this fraction together. So I'm just going to kind of do this part over at the side here. So if I've got negative 1/4 plus 9 over 64, well, you got to get a common denominator. The common denominator is 64. So 64 divided by 4 is 16. So I'm going to multiply that by 16. So I'm going to get negative 16 over 64 plus 9 over 64. Okay, you got to do fraction arithmetic and deal with common denominators. So that will work out to be negative 7 over 64 like that. Okay, so now I'm going to go back to the problem and put that in like that. Okay, does the fraction arithmetic look okay? Okay, you're always going to have to probably get a common denominator and put them together. Okay, but again, no decimals. All right, now what we're going to do is, again, you can write this as minus 3/8 squared equals negative 7 over 64, like that. Then what do? Square root of both sides. Okay, so it's always kind of the very end step goes like that. So you do square root there, you do square root there, you're going to have x minus 3/8 there. Now, when you deal with this, now you're going to have a plus or minus. Now, I'll just do this at the side. If you have a square root of a fraction, you can do the square root of the top and bottom separately. All right, what's the square root of 64? 8. How do you write the square root of negative 7? You have that I thing there, right? I radical 7. So you got to write it like that. Okay? So if you're doing a square root of a fraction, do the square root of top and bottom separately. Okay? Now, you got one more step and you're done. So you need to move the 3/8 to this side. So it's going to be x equals positive 3/8 plus or minus I root 7 over 8. And that's okay if you stop there. That's not wrong to stop there. But we already have a common denominator, see? So what you could do is write this as 3 plus I root 17 all over 8 like that. So either of those two answers, that one or that one, they're all the same. Okay, like that. Now that problem's a little harder just because of the fact that it has fractions in it. Okay? So do you guys got any question about how I handled the fractions or anything in that problem? Yes? No? Is that fairly good? Okay. All right. Okay. Well, I'm not going to do anything with 19. It's the same problem. Can you guys see it's the same problem? Yeah? Okay. I don't know why I put that on there. So, all right. Well, let's go ahead and we'll pause here, and I'll let you guys take a break until 1 o'clock. Then we'll come back and do a few things, but mostly what we're going to do is review for the test. Okay?